welcome. My name is Marit van Dijk, and I'll be talking to you about reading code today. So, as developers, we spend more time reading code than we do writing code. We read code when we're adding features or fixing bugs, or when we're trying to understand a new code base or a new to us code base, when we're doing code reviews, learning about new technologies, doing interesting exercises about how confusing Java is, like in Natalia's talk earlier today. So lots of times that we are reading code and that we have to understand existing code before we even write any code. So research has shown that developers on average spend as much as 58% of their time comprehending existing source code. And that's a quote from The Programmer's Brain by Feline Hermans. Feline Hermans is a professor of computer science education at Vrije Universiteit in Amsterdam. And her research domain is teaching programming. So even though we spend more time reading code than we do writing it, we don't practice reading code much. We don't practice reading code explicitly. We learn programming by writing lots of code, but not necessarily by reading lots of code. And also, just a small disclaimer for this talk, or in general, whenever we do talk about readability of code, often we're talking about how to write readable code, and we're still not talking about reading code. So my talk is not going to be about writing readable code. Other people are talking about that. I'm talking explicitly on how can we get better at reading code, how can we practice that, and how can our tools help. So this is Feline. Feline did a talk at Strangeloop in 2019, if I'm not mistaken, called How to Teach Programming and Other Things. And in this talk, which is amazing, and you should go see it, because I really like her enthusiasm. In this talk, she talks about research from 1992. That's before I learned programming. And in this research, they had a class of students who had to learn programming concepts. And they split the class into 3 different groups. The first group would write and read code. The second group would write code and read code, but that code had explanations. So it had annotations on why certain decisions were made in the code, why certain implementations were chosen, etc. And the third group only read code and the explanations. And what they found in this research is that actually the second and third group, so the ones that read code with explanations on why certain choices were made in that code, were better able to reproduce the programming concepts that they were supposed to learn in this class over the first group who were writing and reading code. So even though we all learn programming by writing lots of code, we should maybe consider reading more code, and then especially code that is annotated with why certain choices were made. So after that talk, someone came up to Feline and said, so what if we do practice reading code explicitly? And that's how Code Reading Club was born. So they started basically as an experiment. They started a code reading club where they would take samples of code and do deliberate exercises on trying to make sense of that code. And I heard or read about that because I follow Feline on Twitter. And I was like, that sounds super interesting. I want to do that. And then I got really lucky because a friend of mine reached out and said, do you want to join our code reading club? So we've been doing monthly sessions of code reading club with a group of people who live in different countries, work in different roles in different companies with different programming languages. And we have monthly online sessions that we take turns facilitating. Not everybody can come all the time. Sometimes I travel and I can't make it. But we've been doing this club for about a year now, I think. So what we do in this club is we take a printed sample of code, and then we do structured exercises. So during the exercises, we annotate the code on a piece of paper. We use lots of colored markers, which is fun, because when do you get to play with colored markers as an adult? So I'll tell you a little bit about the types of exercises that we do. So the first exercise that we usually do is called first glance, and that's literally what it is. You have a piece of code, you take 1 minute, and you just write down what the first thing is that you notice about this code and why. And what's really interesting about that exercise is that people notice completely different things for completely different reasons. So some people might notice, oh, hey, I know this concept, and I know what that means, and that gives me a hint what this code is about. Or, okay, I've never seen this syntax about, and I need to know what it means before I can try to make sense of this code. And also, I've been giving some code reading workshops. There's always people in the group who try to figure out what language it is, which is very amusing to me because that's not at all the point of the exercise, but seems to be very important to some people. The next exercise is we'll identify components and their relationships. So we look for the variables, the methods, any objects that are instantiated, and how they are used throughout the code, which will give you a bit of an idea of the flow. We have an exercise where we determine the 5 most important lines in this piece of code, which is also an interesting exercise, especially if you don't agree up front what most important means, because then people choose different lines for different reasons. So, for example, you might choose the lines that help you to understand the meaning of the code, which might include the class name, or a comment, or the name of a method. You might select the lines that determine the control flow through the code. Or we have some testers or former testers in our group. They would select the lines where, you know, decisions are being made and, oh, I need a bunch of test cases here. So those are the most important lines. So it's also interesting that they notice different things in the code. Another exercise is to identify concepts in the code. Sometimes you need knowledge outside of the code base on the concepts that the code deals with. So it can be helpful to find those so that you have a list of stuff that you might want to research if it was code that you're actually working on. And usually within our group, if we have unknown concepts, someone in the group will be able to explain it to everyone else in the group. And then finally, we take some time to jot down a summary of what we think the code does. And what I find really interesting is that even though the previous exercises don't really look at the meaning of the code or what the code does, by working with the code through these exercises, we're usually able to somewhat figure out what the code does, which I find extremely interesting. So I really like doing Code Reading Club. I would highly recommend trying that out. For me, I learned about reading code, obviously, some exercises that you can use if you're trying to make sense of code. But what I liked even more is figuring out other people's perspectives, because usually you're working on a code base with other people, so it's really interesting to know how they see the code or what they notice about the code and why, because it might be completely different from what you notice. But also what I learned is that by discussing the code and telling them, okay, this is what I noticed and why, it helps me to make my own assumptions more explicit. Because people would notice, oh, I noticed this thing about the code, and I'd be like, that's interesting because I completely ignored that part and didn't find it important in trying to figure out this code. So it also kind of gives you a bit of metacognition on how you read the code. So the most important thing about Code Reading Club is that we're reading the code not to judge, which is what we often do when we read code. Of course, it doesn't help that we read code a lot as part of code reviews. But the point of Code Reading Club is really to read the code to understand the code. And I think that that's a skill that we can all practice. I don't know if you've ever had someone join your team and basically be like, oh, all of this code is crap because it's not how I would read it. One of my former teammates is here. She might know who I'm talking about. Anyway, so, or when you join a new team and the code is, again, completely different from how you would write it, and you might be, instead of being like, oh, this is crap, I want to change everything, maybe take a second and think about, okay, why is it this style? It might be, you know, what they're familiar with. There might be reasons that you don't know. You can actually learn something. And I think it can be helpful for all of us to take that second and, you know, figure out why is the code this way instead of, oh, this is not how I would write it and therefore it is crap. once you know the reason, you might still think it's crap, but you know, at least take a second. So in Felina's book, she also discusses reasons that code can be confusing. One being a lack of knowledge, so things that you know that you have stored in your long-term memory. A lack of information, so information that you have right here that you can work with. Or a lack of processing power in the brain, when things get too complicated and you can no longer fit everything in your mind, basically. So these are tied to cognitive processes of your long-term memory, short-term memory, and working memory. A lack of knowledge can be either in the programming domain, so a language you're not familiar with, syntax you don't know, programming constructs, design patterns, algorithms you don't know, or it can be in the business domain, so domain concepts or business logic that you don't know about, especially if you've recently switched to a different company or a different industry. You might not know everything about the domain that you need for the code base. So dealing with a lack of knowledge, it can help to create a list of the things that you don't know that you can then research. And I don't know if you've ever been looking at unfamiliar code and found stuff that you don't know and then immediately go Google it and end up down a bunch of rabbit holes. Not just me, okay. So it can help to create the list of the things that you want to research, to kind of give you a bit of a frame for these are the things that I should be researching before you go down all the rabbit holes. And sometimes there might be some knowledge that you'd need to memorize because you'll need it a lot in working with this code base. So lack of information could be, could be unknown details. So for example, the code uses a library method that you don't know the details of. Or unfamiliar names, especially again if you're in a new domain, for example. Code can be connected in unknown ways. So, you know, is this code used only here or is it used in multiple places in the code base? Obviously your IDE can help you with the latter, but you might not have that information right there. Or there can just be too many things going on at once, really complicated data flows or variables that keep changing, lots of different ways. So dealing with a lack of information, Felina recommends chunking. So who's ever heard that you can remember 7 plus or minus 2 things in your short-term memory? Lots of people. Funny, that's also what I learned in psychology 25 years ago. Turns out it's actually less. It's 2 up to 6 things that you can keep in your short-term memory at one time. So if you have some syntax that you're unfamiliar with or a design pattern that you're unfamiliar with, you might use all of the elements of that pattern and not see the bigger pattern, and each element might take up a chunk in your memory. So identifying patterns and then storing a pattern in one slot in your memory can help you hold more information in your memory, basically. So finding concepts and patterns can help. A lack of processing power in the brain can be, again, if there are too many processing steps or too many variables to keep track of. And ways to deal with that is by using memory aids. So for example, a dependency graph or a state table. So a dependency graph can look like this. This is the result of one of the exercises where we identify the components and how they are used throughout the code. The screenshot is from Code Reading Club. I have no idea where the code is from, just in case anybody wants to ask. So the dependency graph can help you to visualize the flow throughout the code. A state table can help you to keep track of variables. I'm using a relatively simple nested loop of just 2 variables, but I'm sure you can extrapolate to code bases you've worked on where there was a lot more going on and way more complicated variables to keep track of. So creating a state table can help you there. Felina was writing another book called Code Reading in Practice, which was on O'Reilly's early release program. But unfortunately, she has put the project on hold, so it's not currently available anymore because she's working on other stuff. So I'm sure she'll come up with other amazing, interesting things. But unfortunately, the book is no longer available. I did manage to read the earlier release version. And in the book, she talks about different dimensions of code reading, being structure, domain, concepts, and contexts. So in terms of structure, we know that code is not read linearly. It's not run linearly either. We don't read code from start to finish. In terms of domain, we can think of behavior as well as data that the code deals with. In terms of concepts, we've talked about programming concepts versus business concepts. And in terms of context, an application doesn't usually exist in a vacuum. It can be part of a bigger landscape. It can communicate with other applications. There can be history of how this code came to be and why it is in the shape that it's currently in. So let's take a look at how we can then familiarize ourselves with existing code. First of all, if we are onboarding to a new company or a new team, we might have moments where we need to understand a new code base and work on a new code base. So we'll have to figure out what does this code do. And for that, we'll also need some context. What purpose does this application solve? Who are the business users? What are the other applications in the landscape that it communicates with? I know that for some of the teams I was on, we would do this as part of onboarding. When someone joined our team, we would take an hour to talk about a certain application, be like, okay, this is what it's for, this is the place in the landscape. You take a whiteboard, you explain a little bit, just so that they have some context of the code base. But obviously, at some point, you're going to look at the code. And a good place to start is to just check out the project. And then, of course, your IDE can help you. I'm going to use my favorite IDE for obvious reasons, which is IntelliJ IDEA. So, for example, if we're looking at a new code base, anybody familiar with the Spring Pet Clinic? Okay, some of you are. So Spring Pet Clinic is a demo application by the Spring team. It's relatively small. It's a demo application, so you know there's a good README that explains everything. Naming is fairly proper. But let's say we work on an application like this and we need to figure out what it does. So we can look at the code. And we can open the different packages to look at what's there, to get a bit of an idea of what the code is about. So we see that we have clearly some classes in the business domain and some more in the programming domain. It's not a huge application, there aren't too many packages, so we have a bit of an idea of what this code might do. The next thing I like to do is make sure that I can actually run the code, which is always a good idea before you start making changes, because, well, some of you are laughing, you know why. I also found out the hard way. So, you know, it's good to know that you can run the project. Also good to know that you know how to run the project, that you have everything installed, especially if you're joining a new company and you have a fresh machine where you need to install stuff. So that's useful. You might want to run the application so that you can actually see what it does. That might not always be possible, of course, but in this case it's a small microservice, so let's start that up. And now localhost should work, so we can have a look at the application. It is a pet clinic. The name gives it away. We can look at what different endpoints there are. They even added an error endpoint so that we can see how errors might be handled in Spring. We might want to use an AI assistant to help us figure out the error if your application is throwing an error and you don't know why, because not all error messages are created equal and not all of them are equally helpful in what's actually going on. You can use an AI assistant to, I'm using JetBrains AI assistant, again, for obvious reasons. You can use it to explain the error message to you. And in this case, the default prompt is to explain and say how to fix it. Obviously, this error is there on purpose, so we don't actually need to fix it. Let me stop the application again. So with all of this information, I think we have an okay overview of what this application does, and we might feel comfortable making changes to it, because again, it's relatively small. If we have a bigger application with many more packages, it might be harder to get started. So another example I'll use is the Cucumber JVM, which is the Java implementation of Cucumber, which is a behavior-driven development framework. Not necessarily relevant for the rest of this demo, but as you can see, it has a lot of packages. So here, if we want to figure out what this code does, it might be harder to find a place to start. Now, I happen to know that each of these, or most of the packages anyway, have a README that can explain what they are, but there are like 10, 15 packages, so it might take us some time to read what everything is, and we might want to figure out what a good place is to start. So there's another feature called dependency matrix that you can use, and that will generate a matrix of the packages or classes. So as you can see here, we have the same packages that we have here, but they are sorted differently. The ones that are used by other packages are sorted towards the bottom, and the packages that are using them are sorted towards the top. And we can see how many times they are one package is using another. So if there are dots, then it's more than 99 times. We can click them to see the directionality. So green uses yellow. So in this case, Cucumber Java uses Cucumber Core, which makes sense because the Cucumber Core package defines the behavior, and Cucumber Java is an implementation of that behavior. And you can see that there's a Cucumber Java and a Cucumber Java 8 implementation. The Java 8 implementation uses lambdas, which is why it's called Java 8, because that's when lambdas were introduced. Not the best naming, and if there were any cyclic dependencies, they would be marked in red. So you can use this to figure out the relationships between the packages, so we could click through it and create a diagram for ourselves, or just focus on the parts that we're actually interested in. We can also generate a diagram. No, wrong one. Let me select it from here. So we can create a diagram with the project modules. This will only give us half of the matrix, so only this package uses these other packages, but not the side of other packages are using this package. But by generating these diagrams, that will also give us an idea of how all of the packages are related. Feline does recommend drawing your own diagrams, even though it can be very useful to generate diagrams in your IDE to give you a bit of information. If you're drawing your own diagrams, then you'll be better able to reproduce that information because you've more actively worked with it, but also you can focus on just the parts that you are interested in. So when familiarizing ourselves with a new project, we can look at the project structure, we can make sure that we can build and run the project. We can look at the README, I didn't mention that. So obviously if the way that you normally run a project doesn't work, then check the README to see if the README has the information on how to build and run the project. I've worked on teams where they would have different ways of running each application. So they had like 5 or 7 microservices, and the README would be literally, this is the repo for project X. And then one would be built in Spring, because it was pre-Spring Boot. One would be using Jetty, one would be using Tomcat. Each one would be built and run in a different way. So one of my first contributions was adding to all of the READMEs how to actually run the project, because I'm old and I can't remember. So hopefully that information will be in the README. If it's not there, put it there for your new teammates. Future you will thank you. Also, one of the things I often look at is dependencies, because I like to know what libraries are being used in a project. So I might look at the POM XML to see what libraries are being used in a project, to know if those are the ones that I'm familiar with, or if there are any that I'm not familiar with. I'll add those to my list of stuff to research for a second. I also like to see how up-to-date they are, just to get as one of the measures for the state of the code base. Slightly judgmental, so please forgive me. And use diagrams, and especially draw your own, because working with drawing your own diagrams will actually help you remember that stuff better. So outside of the code base, also look at the components of the code base, identify relationships and dependencies, identify concepts that you might need to know more about, and gain context of the application, because not everything can be captured in the code. A next way that we can dive into a code base is by looking at a specific slice of the application, and that might be related to the task that you're working on, or you can just look at a slice of the application as a way to familiarize yourself with the application. So for that, we need to find a starting point, and that starting point can be either generic, like a main method or an endpoint, to give you an idea of what the application does, or it can be specific, especially if you're working on a specific task, like finding an error message or an exception and where that is thrown, or specific logic or functionality that you need to fix a bug in or make changes to. So obviously here again, your IDE can help you. So for example, we can look for the main method, which will give us lots of hits. So obviously, who's using Spring? Maybe who's not using Spring? Okay, so about 1/3. So obviously, if you're using Spring, the main method is where the Spring magic starts. So it's not a very useful place to start figuring out an application, but for different types of application, the main method might be helpful. In this case, going to a controller might be more useful. We can look at the specific endpoints that will give us an idea of what endpoints there are, that will give us an idea of what the application does, but also from the endpoints we can drill down and navigate from the endpoints to a service layer if there is one, or to the repository and back up again. So we can use the endpoints to go from the outside in and back out again. We can also use the endpoints tool window to navigate to specific endpoints and get an overview. Your application might have a Swagger page. Hopefully that will have some documentation as well of the objects and entities that it deals with. If we have a larger application, you might be looking for a specific error, like where is this error thrown? So we can look that up in the code. Obviously, then we'll want to figure out where we are in the code, so we can use this little target icon or the relevant shortcut to find where we are in the project, to give us a bit of context again. So basically, you are here in the code base for the code that you found, and then you're starting to read basically more bottom up, so from the specific place in the code, and then where is it called from, and then you work your way out from there. So when you're looking at a specific slice of the application, then searching and navigating are very helpful. Strategies outside your code base is to, again, look at a specific use case and to draw your own diagrams of the relevant parts of the code. Finally, you'll find probably a specific piece of code that is where you need to make the changes or where you need to fix the bug and that you need to understand. This is, again, where structured exercises can help. One of the applications that we worked on determined the status of order items for an online retailer, which took data from about 10 different services, or at least I know that it was tracking at least 10 different variables to determine that status. And the code that determined that status was, I think, the most complicated piece of code that we had. So sometimes you have a piece of code and you're just like, I don't even know where to start. And this is really where the structured exercises can help you. But obviously your IDE can help as well. So I have a demo application that is an order service because that's what I worked on. Obviously in your IDE will give you hints. They will give you syntax highlighting for keywords and variables. You can have gutter icons that give you information, inlay hints that give you information. So your IDE gives you a bunch of information that you don't have if you have black and white printed code in a book or during a code reading club. So when we are reading code, again, we're not reading it from start to finish. We actually scan the code, so we use the white space as well to help us make sense of the code. And actually, the more experienced developers are, the more they scan the code rather than read code. So I think in like the first 30% of the time, they will have scanned 70% of the code, and then from there go into details. So obviously, we can use the white space to help us with that. But there are some other ways as well, so we can, for example, collapse the code so we can see only the methods, and then expand the sections that we're interested in. Or we can look at the file structure to give us an idea of what the methods are before we dive into the details of what those methods do. Or if you prefer to have that off to the side, the structure tab, which will give you the methods. You can also use that to navigate to them. So in terms of the structure, we can use code folding to fold the bits we're not interested in and expand the ones that we are. Obviously, if we are writing code in an IDE, the IDE will format the code properly for us. But if we have code that isn't properly formatted, which is the fun part of being a developer advocate, is messing up code to fix it. So if we have a code that isn't properly formatted, we can reformat the code. Hopefully you'll use linters or check style or stuff to fix this for you, but if not, then you can use your IDE. If we're reading code in the IDE, we can also reorder it. Obviously, we're trying to read the code to understand the code, so we're not necessarily trying to make changes to it, but sometimes it helps to play with the code for understanding. Sometimes it helps to restructure the code a little bit. There are also other ways that we can pull up additional information. We mentioned that one of the reasons that code can be confusing is because we lack information. For example, we might not know exactly what a customer order is in this case. Obviously, we can navigate to that code, but if you do that for all of the objects that the code works with, you might end up kind of getting lost in the code. So we can also pull up quick documentation right where we are so we don't end up getting lost. Or if we want to see the code right here without navigating and, again, going down a bunch of rabbit holes and getting lost, we can see it here as well. We have inlay hints to give us the type, but if not, we can pull up type information. So there are lots of hints that we can also pull up if we, not down, up. Okay. So we can pull up information about the code as we need it. We might be interested in the behavior of the code. So we might want to look at the tests. You write tests, right? Okay. I don't know if that giggles means no, we know we should, but we really don't, or anyway. So hopefully there are tests associated with your code. Hopefully also the names of the tests give you an idea of how the code should behave. I did a talk on testing 2 years ago at JSpring where I rant a little bit of how not to do that. But yes, I have found tests named test scenario 1 and test scenario 2, which is super useful because if that fails, you know exactly what's wrong, right? So please, please don't do that. Please make sure that your test expresses somehow of what the behavior should be, so that if this test fails in the future, you know what's wrong and you know maybe what to fix, or if you're making changes, that this is behavior that actually should change as part of your test. So we can debug a test. I should have already placed a breakpoint. So we can run a test through the debugger to actually observe how the code behaves. If you're looking at a piece of code that doesn't have a test, now would be a good time to add a test so that you can exercise that piece of code and run it through the debugger and see what happens. So if we run the code through the debugger, we can see the state of our variables and our objects and everything. We can see our call stack. And we can either step into a method to go to the method that is called on that line, or step over a method to go to the next line. We can also, this is one of my favorite features, evaluate expressions. Obviously, we can already see the state of the variables, but maybe we want to evaluate something that we don't have. And we can actually write our code right there and evaluate other expressions than the ones that we have. So I really, really like this feature especially if I'm like fixing bugs and I'm not exactly sure where I should be going. I can just try it out and then write the code. Nope. Yeah, running code through the debugger can be super useful to figure out what the code actually does. And it's one of my favorite ways to figure out that what I think it does is actually what it does. Or, you look at the bytecode if you're slightly nerdier than me. There's not a lot of room there, but Natalia found it. Anyway, so look at the tests, hope that they serve as kind of a runnable documentation. Go back and look at your test methods and whether they express what the code should be doing, and maybe fix that. Look at the debugger. So finally, we might want to play with the code a little bit and see, like by playing with it, kind of verify our understanding as well. So obviously, IDEs are really good at refactoring. So if we're working with code and we figure out, oh, actually this item right here, that is actually an order item, we could rename it. Especially if you have single-digit variables, as you figure out what the stuff actually means, maybe refactor, rename to give it better naming. By now, we are all used to streams, right? But maybe if we weren't, we could use an enhanced for loop. Or if we have an enhanced for loop and we're actually more used to streams, we can change the style of the code a little bit. Most of these are under Alt-Enter if you're using IntelliJ instead of as refactorings. We might want to extract a method and say, okay, this cancels the order item, so that we take that out. We might want to inline variables if we don't actually need them, or rather extract them. So if we're working with the code, we can extract methods to make it into smaller steps. We can extract variables to give a name to, oh, this is the result of this operation. We can work with refactorings to kind of change the shape to the code to match our understanding. And we have tests, so we can run the test to make sure that we didn't break anything. We might want to find out why or when the code was last changed and why. So I like to always do a little bit of Git archaeology. My ex-teammate here is nodding. So we can go open the Git annotations and go to a specific commit and find out what was changed and hopefully why. You all write good commit messages, right? AI assistant can help you with, sorry. I'll shut up now. Anyway, so if we have, when we find the commit, we can hopefully in the commit message see what was changed and why. In my previous job, we would also add the Jira tickets as a link so that you can go back to the Jira to find out why, the background of a particular story of why these changes were made, so you have some context outside of the code base. Obviously, we can look at the diff of the code to figure out what exactly was changed in the code. In this case, we added logging. Or we can ask AI Assistant to give us a summary of what happened in this commit. So if you have a large commit with lots of files changed, we can ask for a summary. And then you can still look at the exact changes in the code, but you can also ask for the summary. We can close the annotations again. Also, if you don't know all of the refactorings that I just did, there is a list that you can get. And depending on where you ask for the list, it will have more or less in the list. I can't find the fully extended list. Anyway, so there's ways to figure out what refactorings are available. Let me look at my agenda again. Yes, finally, we can ask AI Assistant. Let's find an interesting one. Yeah, so who's good with regex? One of you. Wonderful. So I'm not. So there are several things that we can do with regex, but one of my favorites currently is to ask AI Assistant to explain the regex to me. And I think actually with this type of explanation, I might too be able to properly learn regex. Yay. So that's a fun one. Another one is that we can ask to explain this code to me. We can select which part. No, we don't want to mess that up. So we can ask it to explain code to us. I think that Lisa just showed us that it's super, super easy to generate lots of code now. Which actually makes reading code an even more needed skill because we need to evaluate the code that was generated for us. So actually some of my favorite features from AI Assistant are the ones that help me understand existing code rather than generate code. I can show you generate code too, but it's outside of the scope of this talk. So yeah, lots of lengthy explanation about the regex. We can also write documentation. Obviously, you might not add javadoc to a private method, but I'm just showing you that you can. So documentation is also solved. So lots of ways that your IDE can help you when reading and trying to understand code, from ways that you can deal with the structure of the code, hints that your IDE gives you in terms of syntax and inlay hints, etc. Looking at the tests, running them through the debugger, refactoring and playing with the code, restructuring the code for your understanding, obviously roll all of that back at the end, and providing you with some context outside of the code base. Outside of your IDE, structured exercises really can help. I'll have another slide of where you can find some exercises, and I've added a few at the end of my slide deck that I'll share with you. Using memory aids like a dependency graph or a state table, and just gaining some context of the code base, its place in the landscape, other applications that you're working with, etc., can help. So what might be next for you? If you're interested in doing code reading exercises, either by yourself or with your team or with some coworkers or with some friends, Code Reading Club, they have occasional online events. I forgot to check today whether they have anything planned, but you can go to their website. Also, there is a link to their Discord if you want to go talk to them and ask how how they're getting on with their clubs, or if you start a club and you want to share your progress. They have a GitHub repository with resources for at least 3 sessions, so with a code sample and exercises that you can do and notes for a facilitator on how to do the exercises if you've never done a code reading club before. Finding code samples that are short enough to print on a piece of paper but still have something going on is harder than you'd think, so it's worth it for the 3 code samples alone. The Programmer's Brain by Feline Hermans, which I think is an amazing book for any programmer on, you know, just how our brains work and how that translates to our job and to get better at it. But also she has a lot of exercises in the book that you can apply to your own code bases or that you can reuse for Code Reading Club. Obviously, let your tools help you. And don't forget to use your brain, because even if you're, you know, generating the code with an AI assistant, you still have to evaluate that code and make sure that it's what you want. So with that, here's a link to the slide deck. And quickly, oh wait, I forgot. So and don't forget to rate in the app. Thanks.